Yes, tell me whether the slide is visible.
Yes, sir.
Yes, sir, it's visible.
So in our previous class, we had discussed up to threats. So vulnerabilities and threats, isn't it? So impersonation, worms and viruses comes under threats. Denial of service, unauthorized access also examples of threats. Now risk. So what is called a risk? What is called a risk? Software risk, hardware risk, network risk. So there are three types of risks normally: software risks, hardware risks, and network risks. So risk may happen or may not happen. So there is no surety or guarantee for risk occurrence. It may happen or may not happen. So we can calculate the risk of the network with the formula threat into vulnerability into impact. Threat into vulnerability into impact. So this is the formula for calculating the risk. So here risks arise from unauthorized access, unintentional errors or omissions, IT disruptions, and failure to exercise due care. So this is somewhat exceptional. So that is why we can say that a risk may occur or may not occur. There is no guarantee that risks occur
Sir,
in
can
the
you repeat risk?
application.
Sorry, sir. I joined just now. Can you repeat risk?
Yes, risks. Today we will start with risk. So what is called a risk? Risk may happen or may not happen. So there is no guarantee for risk. So risks are classified into three types of risks. Software risks. I think you might have studied about software risks in your software engineering course. I think all of you might have studied software engineering course, isn't it?
No, sir. No, sir.
No. Okay.
No, sir. No.
No, sir.
In software engineering, software risks and hardware risks are classified. Whereas in network security, we will discuss about network risks. So risk is not a reality. So it may occur or may not occur. So we cannot say that a risk may really occurs. So that is the case here for risk. So the risk of the network can be calculated with the formula called threat into vulnerability into impact. That is the formula given here. Threat into vulnerability into impact. Next, risk analysis. We can just analyze the risk, whatever the risk which is present in a network. We can analyze the risk by identification. First, we have to identify what is the type of risk. Next, assessment. We have to just assess the risk such that does the risk cause huge failure or less failure. If the risk damage is very high, then we need to resolve the risk immediately. If the risk damage is very low, then we can just ignore the risk and we can just deal with the risk at the last after the operation is done. And next, and reduction of risks to an acceptable level. So there is some certain level in the network also where risk is acceptable. Even though there happens a risk, then also the network can tolerate those risks. So that is why we have to reduce the reduction of risks is to be done up to that acceptable level. So that is the case here. So the process of identifying security risks and the probability of occurrence. So the probability of occurrence, I told you that the occurrence of risk may be or may not be. It is 50-50 chance. So that is the probability of risk occurrence determining their impact. So what is the impact of the risk? It will cause heavy damage or less damage. And next, identifying areas that require protection. So if it causes heavy damage, what are the areas which requires more protection and what are the areas which doesn't require protection? So all these things are to be identified and analyzed. So that is the main purpose of risk analysis. So three parts of risk analysis are important, that is risk assessment, risk management and risk communication. So first, risk assessment determines the possible risks. So what type of risk, whether it is a heavy loss risk or low loss risk. Next, risk management, evaluating alternatives for mitigating or solving the risk. So how to make the risk solvable. Next, risk communication, presenting this material in an understanding way to decision makers and or the public. So how this risk, whatever the risk which we are dealing with, how this risk can be communicated to the users in an understandable manner, such that the users can think of the risk, they can think about the risk in a positive way, such that this risk can be acceptable. So that is the case here, 3 parts of risk analysis. Next, risk management versus cost of security. So here,
Sir, what is communication? Sorry, what is communication, sir?
here it is present now. Then why are you asking again and again the same? Yes,
Oh, sorry.
I'm just
No, sir.
telling it. I am continuously observing this guy. He's continuously asking for repetition. I don't know why. I'm going in a flow and you are just obstructing my flow.
Sorry, sir. Sorry, sir.
It is full of theory course and it has lot of theory part. I have to just recollect all the data and have to tell here. You are continuously asking me to say, to tell the previous one. If you abstract like this, how can I say? You just tell you be situated in my place and think.
Sorry, sir. I understand.
Yes, it is easily understandable here. For your purpose only, I had just prepared the slide in a very easier language. Then also you are continuously asking me, yes, please repeat me like that. It doesn't matter that I can repeat you, but how many times? Just previously you told that you came late. That's why I told the topic again, risk again. Now also you are asking for repetition. Okay, let it be. So presenting this material in an understandable way. So I told you that risk may occur or may not occur. So here the users, whoever dealing with the risk, so they have to just solve the risk and they have to communicate about the risk to the other users in such a way that that risk is easily manageable. If that risk is not manageable means then they have to communicate about that risk as it is not easily manageable. So to the public, they have to deliver the communication about that particular risk, stating that it is either easily manageable or difficultly manageable. Next, risk management versus cost of security. So here, risk management is quite related to cost of security. So whenever the risk is high, cost of security is low or high? You tell me what is the answer for this.
Hi.
Whenever the risk is high,
Hi,
if
sir.
we are having the risk is high, risk in a high way, next cost will be also very high. If the risk is low, the cost of security will be low. So like that, risk management and cost of security are directly proportional. Okay, so here risk mitigation. So solving the risk is the main task here. Whenever the risk is solvable, then the cost of the security will be reduced. Whereas whenever the risk is not solvable, then the cost of security will be very high. The level of acceptable risk. So whenever the risk is acceptable, then the cost of security is somewhat moderate. Trade-offs between safety, cost and availability. So there will be some trade-offs between the safety, security and cost and availability of the risks. So these are the things here. And next, site security model. So we will be having a layered site security model here. In this outer perimeter, see here, these are the layers. First layer is outer perimeter, that is the fencing or building doors. So fence or building doors will become the outer perimeter. If we are within if we are present within an organization with internal servers. So here, if we see the figure, the last layer is locked servers. So this is the internal server which is locked within our organization. And for this server, we are having 4 layers of protection. What are the 4 layers? Site security layers, outer perimeter, that is building doors. So first, building doors is the first security. Next, guard desk. Guard desk is the second layer. And next, third layer, internal perimeter, that is elevator or office environment. And next, in whatever the environment which we are using that particular network. And next, data center access. And this data center access deals with who are the users, who are the authorized users for whom the access permissions are given with the network. to deal with the server. So like this, there are totally 1, 2, 3, 4 layers for the servers, internal servers which are present within a site security. In order to provide site security, these are the four layers of security which we need to handle. So see here, understanding site security process. So here, see the topics over here. It is full of theory. I will just highlight some text here. See this. In the external parameter, you might have a process to manage entry to the parking lot. So here I told you that external perimeter deals with fencing and building block, outside building block. So it will be managing the entry to the parking lot through a gate, and or there may be a process for how often the guards patrol the parking lot. So here in the entry level itself, we have to restrict the unauthorized access. So that is the main objective here. And next, in the internal perimeter, you might have the process that include guest sign-in procedures. So in the internal perimeter, in the next layer, we have to just include the guest sign-in procedures, equipment removal procedures, guard rotations, or when the front door is to be left unlocked. So whenever the sign-in is successful, then the front door will be left unlocked. Whenever the guest sign-in is unsuccessful, then the front door will be locked. So like that it will be handled, and there are many other procedures also in this. So once you reach the secure area layer, you will be generally having some procedures for controlling who is permitted to enter the data center and how they will access the data center. So everything, who are the users who are permitted into the data center to access the server, and how to restrict the others, unauthorized people, from entering into the data server. So that is the thing which is the safeguarding mechanism which we are following here. So it is a full of theory. You can just study, no problem. Next, virtual local area network. Next one is virtual local area network. So here the main purpose of virtual local area network is to unite network nodes logically into same broadcast domain regardless of their physical attachment to the network. So this is the main objective here. The purpose, what is the purpose from this statement? We can just say that virtual local area network, it will just combine, gather all the network nodes logically in the same broadcast domain regardless of their physical attachment to the network. Whether they are physically attached or not, we doesn't bother about that. We will just combine together all the network nodes which are logically into the same domain broadcast. So that is the thing here. And next, this creates a boundary and in a sense creates multiple isolated LANs on one switch. So it is also possible for us to create a boundary which generally creates multiple isolated LANs on one switch. We will be having all these things on one switch because switches operate on layer 2, that is the data link layer of the OSI model. So I think all of you know about OSI model. We will deal about this OSI model in the next coming slides. In the same slide, we will be dealing with the OSI model in the next coming. So see here. So FTP servers and external DNS domain name servers. FTP server, what is the purpose of FTP? File transfer protocol. The name itself implies that this particular protocol is used for transferring files from one network node to the other network node. And next, DNS servers. DNS servers means domain name server. So domain name server. So each and every server is named with a domain. So that is why it is called as domain name server, and whoever the authorized users who are having proper permissions, only they alone can access the DNS servers which are present within the virtual local area network. So as we know that local area network is a network which can be accessible only within a particular organization or within a particular limit. So that is the same thing here. Virtual local area network, it will just virtually access all the systems present within a particular organization through the means of FTP servers and external FTP servers and external DNS servers. So that is the thing here. And next, demilitarized zone. Demilitarized zone. So see the figure here, DMZ. DMZ stands for demilitarized zone. So this demilitarized zone will be having a combination of email server as well as the web server. So see here in the figure itself, if we observe the figure, the demilitarized zone will be having an email server and web server. What is the purpose of this demilitarized zone? It is a small network between the internal network and the internet. See here, it is present, this DMZ is present in between the internet as well as the internal server. See here, this is internal server and this is the internet. So this DMZ, demilitarized zone, is a small network which is present between the internal network and the internet that provides a layer of security and privacy. So this provides a layer of security and privacy. Both internal and external users may have limited access to the servers. So here both the internal users and external users may have limited access to the servers in the DMZ. See here, within the DMZ, the internal users will also have limited access to the servers. Why? Because the firewall restricts unauthorized access. And here the internet is connected with a router such that the router is integrated with the DMZ, demilitarized zone, and this demilitarized zone will be having the email server and web server such that the email server will take care of all the mails whichever received from a particular domain, and it will just send that particular mails to the concerned users within the web server. And the firewall restricts unauthorized access and the information is passed to the internal server. So if we look on to this demilitarized zone, so there are some certain ports within a network. Within a network, we will be having some certain ports. So 21, 22, 25, 53, 80, 110, 443 are certain ports which are providing some certain services through the means of protocols. So FTP is file transfer protocol, which is providing the service of FTP, file transferring, in the port number 21, and in the same way 22 is the port number, and SSH stands for secure socket host. And next 25 port number SMTP, simple mail transfer protocol, and 53 port number DNS, domain name service. 80 port number, it will provide the service of hypertext transmission protocol, and 110 is the port number which provides the service of POP3, that is post office protocol version 3, and 443 hypertext transmission protocol server. So these are the ports and services which are provided to the DMZ, demilitarized zone. So see here, table lists the most common services and ports that are run on the servers inside the DMZ. Within the DMZ, we are having web servers. So these are the services. File transfer through email service, we can just send one file to the other file, and it can just provide security, and simple mail transfer protocol will just send the mails from the email server to the web server, and domain name server will also integrate with that, and HTTP hypertext transmission protocol will also involve in the data transmission there, and post office protocol version 3 is taking the responsibility of delivering the mails from one system to the other system within the network. And superior version of this HTTP, hypertext transmission protocol, yes, so it will be sending the text transmissions, whatever the text transmissions which we are transmitting there, it will be sending them to the appropriate server in a very superior way. And next, TCP IP. All of you know about transmission control protocol. I think you might have studied about transmission control protocol. You tell me whether TCP is connection oriented or connectionless. TCP, Transmission Control Protocol. Is it a connection oriented protocol or connectionless protocol?
Connectionless.
Correction oriented.
Connection oriented. Transmission Control Protocol is a connection oriented protocol, whereas user datagram protocol is a connectionless protocol. So there should be a physical connection in between the two systems which are interconnected through the means of TCP. If there is no physical connection, then TCP doesn't work in between those two systems. since TCP transmission control protocol is connection oriented, we need to have a physical connection between the two systems which are transferring the data through the means of TCP. And next, IP, Internet Protocol, is used by the internet systems such that it will transmit the data through the means of internet. And next, so see here, what do you know about TCP? These are the important things which are to be noted while we are performing operations with TCP and IP. So addressing or multiplexing. So how the data transmitted from one user to multiple users. So multiplexing. So this is taken care by TCP. How the addressing of multiple users, multiple destinations can be performed through the means of TCP and IP. And next, connection establishment, management and termination. So these are the things. Connection establishment, how the physical connection is established between one system and the other system, and how the data transmission is managed here, and how data transmission is terminated here at last. And next, data handling and packaging. So how the data is handled and packaged. And next, data transfer. Data transfer means how the data is transferred from one system to other system within the TCP IP network. And next, providing reliability and transmission quality services. So how much reliable is the data transferred from one system to other system here, and what are the transmission quality services? So we can just say that the quality is very high as the connection is physical here. Providing flow control and congestion avoidance features. So congestion avoidance means no two or more resources should access the same information at the same time. That is called congestion here. Network congestion, which may lead to network congestion. So we can just avoid congestion here through the means of TCP. Providing proper flow control. Next, TCP. All these things are detailedly explained here. Addressing and multiplexing. I told you what is called multiplexing. More number of users will be receiving the information there, and here it is very much simpler sibling. It is having a sibling here which is called as UDP. I told you that UDP is a connection less protocol, whereas TCP is a connection oriented protocol. That is why we need to establish a physical connection between the sender and the receiver, and connection establishment and management and termination is to be properly checked. And next, data handling and packaging is also important here. How the package of messages are handled here, how they are sent to the destination by the use of TCP. That is the thing which is to be looking here. And next, data transfer, how data transfer takes place here. And next, providing reliability and transmission control quality services. So how the quality is ensured here, and how much reliable the data is the data is, like that. Next, providing flow control and congestion avoidance features. So congestion is completely avoided within the particular network through the use of TCP with proper flow control. And next, see here, I told you that OSI model, I told you in the previous slide that in the coming slides we will discuss about OSI model. So this is the OSI model. Here the OSI model is present in the left side and TCP IP model is present in the right side. So if we see the figure over there, the OSI model is having 7 layers: physical, data link, network, transport, session, presentation, application. So these are the 7 layers present in OSI model. Whereas if we observe the TCP IP model here, so the top 3 layers of OSI model is application, presentation and session. So these 3 layers are integrated together to form the application layer in TCP IP. And next, transport layer is as it is present here both in OSI as well as in TCP IP. Network layer is also as it is present in both OSI and TCP IP model, whereas the last 2 layers, physical and data link layers, are integrated together to form the physical layer alone in TCP IP. So in an overall, the TCP IP is having only how many layers? 4 layers: application layer, transport layer, network layer and physical layer. Whereas the OSI model is having 7 layers there. So that is the basic difference here. We will discuss about what are the functionalities of each and every layer in the next coming slides. So how TCP/IP works? How TCP/IP works? So TCP/IP uses a client-server model. Client-server model. I think all of you know about the client-server model. The client will be sending the request to the server, and the server is responding to the client's request. So whenever the client is sending appropriate request to the server will perform the task and the server will respond to the client's request. Here that is the operation which is handled by TCP/IP. That means that for each and every request, which we are performing, we will be getting appropriate result since there is a proper connection established between the client and the server. That is the thing here. Next, collectively TCP/IP protocol suite is classified as a stateless. So we will be having TCP/IP protocol suite which will be classified as stateless. We will discuss about that TCP/IP protocol suite in the next coming slides. The transport layer itself, however, is stateful. It transmits a single message and its connection remains in place until all packets in a message have been received and reassembled at the destination. So it will just confirm whether all the packets in a message has been properly received and reassembled at the destination. So TCP/IP model will ensure proper delivery of the data from the client to the server. So that is the thing here. Proper delivery is surely guaranteed. So for that purpose, we need the support of many protocols within the TCP/IP protocol suite. So these are the protocols: HTTP, Hypertext Transmission Protocol, and next File Transfer Protocol FTP, and Post Office Protocol version 3, and next Simple Mail Transfer Protocol SMTP, and Simple Network Management Protocol SNMP. So all these protocols will be present within the TCP/IP protocol stack. And next, the transport layer is responsible for maintaining end-to-end communications across the network, and TCP handles communications between the hosts and provides flow control, which is multiplexing and reliable. So it will be providing a reliable data transfer. And transport protocols include TCP and user datagram protocol UDP, which is sometimes used instead of TCP for special purposes. Special purposes means whenever we require data transmission without establishing any physical connection, then in that case we will be using the UDP protocol, which is a connectionless protocol. Next one, ICMP protocol. ICMP protocol is the protocol which is responsible for delivering the messages, delivering the mails through email facility. So internet control message protocol. So we can just deliver the message through the means of internet by the use of this ICMP protocol. The network layer protocols are the IP and the internet control message protocol, which is used for error reporting. So within the network or internet, if there is any errors occurring or restricting the delivery of mails such that these errors are properly reported by the use of ICMP protocol. That is the main objective here. The physical layer consists of protocols that operate only on the link, the network component that interconnects nodes or hosts in the network. So Ethernet for local area networks, LANs, and the address resolution protocol, which is used for connecting the protocols in this layer. Next, importance of TCP/IP. So this is already we discussed in what way TCP is important. TCP/IP is important, and TCP/IP is non-proprietary. As a result, it is not controlled by any single company, and it is compatible with all operating systems. TCP/IP is highly scalable as a routing protocol. As we are establishing a physical path between the source and the destination, it is a routing protocol, and it can determine the most efficient path through the network there. Next, I told you that each and every layer will be having some certain functionalities in the OSI model. So these are the functionalities. Physical layer. So to transmit bits over a medium, this physical layer is used. To organize bits into frames, first layer deals with bits and transmits the bits over the medium, and the second layer, data link layer, it will organize the bits into, converts the bits into frames there. And next third layer network, it moves packets from the source to the destination. And next transport layer to provide reliable process to process message delivery and error recovery. And the fifth layer, session layer to establish, manage and terminate sessions. So it will properly establish a connection, manage the connection and terminate the sessions there. And next presentation to translate, encrypt and compress the data. That is properly presented there. Data is properly presented to the destination through the presentation layer. And application to allow access to network resources. So this application layer will allow access to the network resources through the use of many protocols, whatever the protocols which we had discussed in our previous slide, like ICMP, POP3, SMTP, SNMP, all those things. Okay. So next, protocol suite. Already we had discussed about the whatever the protocols which we are using in the TCP/IP protocol suite. So see here, comparison between OSI and TCP/IP is very important here, and layers in the TCP/IP suite. We already discussed about these two. So these are the very important concepts here. So original layers, only 4 layers are present in the TCP/IP layer, TCP/IP protocol suite. That is the application, transport, internet and network interface. And next, see here. So the network interface and the hardware devices are integrated here to form the data link layer and physical layer, which is used in this particular example. So this particular figure is very important, which states that the physical layer and data link layer are merged to form the integration of hardware devices and network interface. See here. Yes, see the figure over here, such that we can just analyze the TCP/IP protocol suite and we can compare this with OSI model, such that the physical and data link layer of the TCP/IP protocol suite and OSI reference model, OSI model is also mapped together, such that underlying LAN and WAN technology is present within the physical and data link layer, and internet protocol and some helping protocols. So transmission is done through the use of internet protocols and some helping protocols. Several transport protocols are present in the transport part, including TCP and UDP. And next, application layer, it will be involving several application protocols like POP3, that is Post Office Protocol version 3, ICMP, Internet Control Message Protocol, and SMTP, Simple Mail Transfer Protocol, SNMP, Simple Network Management Protocol. All these protocols will be residing in the application layer. So see here, security attacks. So there are several security attacks here. I told you about the security attacks and security threats in the previous class. Confidentiality, integrity, and availability are the 3 goals of network security. In the previous class we had discussed about this. So in what way the security attacks and security threats are related? So see here, snooping attack and traffic analysis attack. These 2 attacks comes under threat to confidentiality. Modification, masquerading and replaying and repudiation. All these 4 comes under threat to integrity, and denial of service comes under threat to availability. So we will see about these all networks in the next coming slides. So see here, threat to confidentiality. What are the threats? What are the attacks which comes under the threat to confidentiality? Snooping and traffic analysis attacks. So in the snooping attack is nothing but it is an unauthorized interception of information. So if any unauthorized users tries to access the information which was present in the node, then snooping attack is said to be occurred in that particular node. Some unauthorized entity is listening to the communications or borrows through files or information. So here it will just gather the information unauthorisedly. For example, an unauthorized user intercepts a file transferred through the internet. So if there is any unauthorized user who is accessing the file which is transferred through the internet, then such type of attack is called as snooping attack. So that may be a threat to confidentiality. Traffic analysis, second type of attack. So an interceptor may not be able to tamper with the encrypted data. So here the interceptor may not be able to tamper the encrypted data. They can obtain some other type of information by monitoring online traffic. Instead of intercepting the existing data, they might obtain some other type of information and they will be just changing the information here. So that is the case. It is called as traffic analysis attack. So that also will be a threat to confidentiality. And next, threat to integrity. So here, threat to integrity is the modification of message. See the figure over here. Alice and Bob are connected in the internet, and Alice is sending some information here, which is accessed by the attacker Eve, and this information is modified by the attacker Eve and sending the modified information to Bob. Bob assumes that it is receiving the information from Alice, but Bob is not actually receiving the information from Alice. Bob is receiving the information from Eve, which is an attacker there. So that is called as modification of message, and it is a threat to integrity. And the second type of threat to integrity attack is masquerade. So see here, the same thing similar to modification is masquerade. Masquerading is impersonation of an entity by another. Impersonation of an entity by another. So in modification, Eve is sending the modified message to Bob, whereas here in masquerade, Alice is sending one information to Eve, whereas without performing modification to that particular message, Eve is sending another information to Bob, but which is different from the information that Alice has sent to Eve. So that is the thing, it is called as masquerade. So this is also a threat to integrity. Replaying. See the figure over here. If you observe the figure, the same figure, which is similar to the previous figure, replaying. So Alice is sending some information to Bob, and that information is sniffed in the packet through the attacker Eve. And next, this Eve, what is he doing? He is continuously replaying the same information to Bob. The same packets are transmitted to Bob continuously, replaying. And next, last one, reputation. Reputation is also the same thing. Multiple copies of same data is transmitted. So see here, threat to availability is DDoS. The common threat to availability is DDoS attack. See the figure over here in denial of service attack. So see here, attacker Eve is sending some information to Bob, whereas here Alice is sending some information to Bob. This Bob, what it will do, it will receive it doesn't receive the information from Alice, whereas it will receive the information from Eve, such that it will deny the service of Alice. So that is the thing. Actually, it is intended to receive the service of Alice, but it is not receiving the service of Alice. It is receiving the service of Eve. So that is why it is said to be denial of service attack. So it is very common type of attack. The attacker prevents a server from providing services. So here Bob is preventing Alice from providing services. So that is about denial of service attack. And here we are having multiple denial of service attacks, smurfing, Fraggle. So what is called smurfing? This attack is based on ICMP protocol. Based on ICMP protocol, this smurfing is taking place. Echo reply function. It is most commonly known as ping. I think all of you know about ping. Ping is a command which is used to check the connectivity of the network. So if we give a ping command in our DOS prompt, it will just give the connection issue, connection information, connectivity information of that particular system to the internet. Next, Fraggle. This attack is similar to Smurf attack. So it is also similar to Smurf attack. So here the difference is that it uses UDP rather than ICMP. Whereas in the previous case, Smurf or smurfing, ICMP protocol is used, whereas here UDP protocol is used. And next, ping flood, sync flood, and LAN are the other different types of attacks which comes under DOS. Ping flood. So you just continuously sending ping messages And SynFlood, synchronization message. Synchronization message, continuously sending the synchronization messages, stating that the data is synchronized with time. LAND. This attack exploits the behavior in the operating system of several versions of Windows. So it will just exploit the behavior in the operating systems of several versions of Windows, Unix, and other operating systems. Next, teardrop. Teardrop is also one type of attack which is used in the UDP as well as TCP IP stack, where the teardrop attack sends a fragmented UDP package to the victim with an odd offset value in subsequent packets. So here it makes use of fragmented UDP packets in such a way that it transmits the data with those connectionless UDP protocol. Next, bonk. This attack affects only Windows 95 and NT machines by sending corrupt UDP packets to DNS port 53. So there will be a port called DNS port which is of port 53, and UDP packets will be sending corruptedly to the DNS port here. And last one is BOINC. So this is a bonk attack that targets multiple ports rather than just port 53. So bonk attack is concentrating only on port number 53, whereas BOINC attack it's concentrating on more than one port, that is multiple ports it is concentrating apart from port number 53. So DOS attacks is done. And last one, DDoS attacks, distributed denial of service attack. This thing we'll discuss in the next class. We'll discuss about this distributed denial of service in the next class as the time is up. Okay, let me take the attendance now.